This is Particle Physics, Lesson 3, Photon Energy. So the EM spectrum, or the electromagnetic spectrum. So we should know this previously, especially if you did GCSE. So it consists of radio waves, microwaves, infrared, visible, UV, or ultraviolet, X-ray, and gamma rays. So all forms of this radiation travel at the same speed through a vacuum known as C, and it's 3 times 10 to the 8 meters per second. Interestingly, just to get a bit of perspective, it's 186,000 miles every second. So compared to the world that we live in, it's incredibly fast. And just for your notes, 1 nanometer would be 1 times 10 to the minus 9. So if you ever see NM, means nanometers, times 10 to the minus 9. Okay, let's move on. Just out of interest, and we should really know this, the wavelength of visible light is between 400 and 700 nanometers. And the blue side is 400, the red side is 700. Okay, so the wave equation. So this should be from GCSE. So when it comes to light, the wave equation is C equals F lambda. C being the speed of light, 3 times 10 to the 8 meters per second. Frequency is measured in hertz, Hz. And lambda is wavelength, and wavelength is measured in meters. Okay, so let's move on. Let's apply this. Let's get this written down. So a quick question. Calculate the frequency of violet light if the wavelength of this violet light is 420 nanometers. So pause the video, attempt this question. So our equation, C equals F lambda. So rearrange to find frequency. So frequency is the speed of light divided by the wavelength. So speed of light is 3 times 10 to the 8 meters per second, divided by the wavelength, which is 420 nanometers. So that's 420. And remember earlier we discussed that nano just means times 10 to the power minus 9. So that will give you a frequency of 7.14 times 10 to the power of 14 hertz. Hopefully that's okay. So let's move on from that. So photons. So electromagnetic radiation is emitted as short bursts of waves, each burst leaving the source in a different direction. And each packet of these waves is called a photon. Each photon contains a set amount of energy and is proportional to the frequency of the electromagnetic radiation. So each of these packets, mathematically, you can calculate the energy as E equals HF. That's where the energy being proportional to the frequency comes from. That's this one. So if you want to pause and make some notes, I'll move on. I'll explain this equation in more detail and then give 2 versions of it. So photon energy, as I just said, is energy, the photon energy is equal to H times F. So let's just discuss what these are. So E is energy, and the energy of the photon, or the packet of energy, is measured in joules. F is frequency, measured in hertz. And H is the Planck constant. And the Planck constant is 6.63 times 10 to the power minus 34 joule seconds. So that's a constant. It will be on the data sheet for your relevant exam board. But you should be able to remember it. It is very useful. It's using this equation, E equals HF. So as long as you know the frequency, we know Planck constant, you can get the energy of a photon. So I'm just going to remove this and give you another version of this equation. So make sure you've got this written down. So we've got E equals HF so far. And we've also got C equals F lambda. What I want you to do is to pause and to try and shotgun these together to make one new equation to give energy in terms of wavelength. Okay, so frequency is C over lambda. And then I'm just going to substitute that into this first equation. So energy will be equal to H, and instead of frequency, it will be C over lambda. So HC over lambda. Just another variation of the equation. Can prove very useful. So make sure you got it written down. And then let's move on. So quick question. Calculate the energy of a photon. I don't know why I've put of a photon twice, but there you go. Of wavelength, lambda equals 500 nanometers. Pretend you didn't see that. There we go, that's better. So calculate the energy of a photon of wavelength, lambda equals 500 nanometers. And whilst I'm at it, there you go. Alright, so I'm going to take you through that answer now. So we can use the equation that we just made. So energy is equal to Hc over the wavelength. So the energy will be H, which is 6.63 times 10 to the minus 34 times the speed of light, 3 times 10 to the 8, divided by the wavelength, 500 nanometers. So that will just be 500. Remember, nano is times 10 to the minus 9. So put that in your calculator and you'll get 3.98 times 10 to the power minus 19 joules. Pretty straightforward. So let's move on. Which is sketch this table down, complete it. Be very careful with these units. So that's times 10 to the minus 19, they're all times 10 to the 14, they're all times 10 to the 8. So be careful, and then I'll give you the answer in a few seconds. So obviously pause the video. Okay, hopefully that went okay. Let's have a look. So the answers. You get 5 times 10 to the 14 for the frequency, 3.32 to the power minus 19 for the energy in joules, 3 times 10 to the 8 for the speed in a vacuum, which makes sense because the speed of light is 3 times 10 to the 8. Wavelength of 750 nanometers, or 750 times 10 to the minus 9 meters, 2.65 to the minus 19 joules. Vacuum, once again, 3 times 10 to the 8 meters per second. Frequency, 302 times 10 to the 14 hertz. Wavelength of 10 nanometers, or 10 times 10 to the minus 9. Now, the speed of light, you may be aware of this, may not. The speed of light in different materials will change. So in glass is more dense, so the speed of light will drop. You do more about this when you do optics. So that gives a wavelength of 250 nanometers. And an energy of 5.3 times 10 to the minus 19 joules. Speed of light in water is 2.3 times 10 to the 8 meters per second. And you should get an energy of 3.05 times 10 to the minus 19. That should be pretty straightforward, just substitutions into the equations. So there's 3 equations from this session. E equals HF, C equals F lambda, and E equals HC over lambda. So that's bread and butter of particle physics, photon energy. Hopefully that's okay. Thanks for watching, and I'll speak to you soon. Bye-bye.